Hi, everyone. Today, we will introduce our work titled Decomposition-Driven Multi-Table Retrieval and Reasoning for Numerical Question Answering, which has been accepted for ICDE 2026. This research, a collaborative effort by our team, addresses the increasingly complex challenge of extracting precise numerical answers from vast collections of tabular data. So, why do we need to focus on numerical multi-table question answering? The core issue is data fragmentation. In many real-world scenarios, the information needed to answer a single question isn't conveniently stored in a single table. For instance, if we ask for the total citation count of female Nobel Physics laureates after 2010, we can't just look at one table. We actually need to cross-reference personal details, award categories, and citation metrics spread across multiple tables, such as these tables A and B and C1 and C2 here. When we look at existing solutions, we see significant performance gaps as complexity increases. Current methods often struggle with complex table relationships, showing a 10% drop in retrieval effectiveness. More alarmingly, as we scale from a small set of tables to a massive corpus of 100,000, retrieval effectiveness plummets by up to 40%. Finally, even if we find the tables, generating an accurate answer across isolated data silos often leads to a 20% drop in accuracy. This highlights a clear need for a more robust approach. Our goal is straightforward yet ambitious. Given a numerical question and a massive tabular data lake, we want to effectively retrieve the specific subset of relevant tables and process them to output a single, accurate numerical answer. In our previous example, that would mean taking the question about Nobel laureates and distilling a large scale of tables down to the correct answer of 250. To achieve this, we've developed a four-step approach we call DMRAL. First, we pre-process the data by constructing a table relationship graph to map out how different tables connect. Second, we use a table-aligned question decomposer to break complex queries into simpler sub-questions. Third, our coverage-aware retriever finds the best tables by ensuring every part of the question is covered. Finally, a sub-question guided reasoner progressively builds a reasoning program to calculate the final answer, ensuring the logic remains sound across different data sources. The results of our experiments speak for themselves. Our method, DMRAL, demonstrates a substantial leap in performance. We achieved a 24% improvement in multi-table retrieval effectiveness compared to existing baselines. Even more impressively, when it comes to the final output, we've seen a 55% improvement in answering accuracy, proving that our decomposition-driven approach is highly effective for these complex tasks. To wrap up, we have introduced DMRAL, a framework specifically designed for multi-table retrieval and answering within large-scale table collections. By leveraging structured decomposition and complex table relationships, we've addressed the critical gaps in current numerical QA systems.